In the earlier classes, I explained about the process and process states, how to execute the process in the operating system. Now, in this class, I will explain about the threads. What is meant by thread? Here, whenever you are going to the thread, before going to the topic, I explained about the one programmatical example. One, whenever you write down the program, whenever you write down the program, there is a lot of system defined function or inbuilt function or operating system function and user defined. Both all the functions are included. Now, whenever process is executed, it means your program is executed. On that time, whatever the function you have to execute, that program also you have to execute like a thread. It is a part of a program, that's why you call it a thread. If it is individually that is working, on that time that is called a process. Is that main program is accepted as a process. In that, whatever the program we have to, whatever the inbuilt program, whatever the system defined programs are there, those are all called as a thread. That is the actual actual example in a thread. It means whenever you write down the, for example, you complete the data structure programs. It means you write down the one main function and you write down the insert, delete, update and display. Now here process is called as your main function program name, and what are all the threads is called as a threads. Insert is one thread, update is one thread, delete is one thread, display is one thread. Whenever the execution of program is going on, these are all the things will be generated at the time of executed by the during the operating system files. Here, whenever thread is a accepting as a lower weight when compared to the process. Why the process is a high weight? Why thread is a low weight? Process, number of threads included in a process. That's why process is a heavy weight. Thread individual, if you take a thread, that is called the lower weight. Whenever execution is going on, all the threads input value or output values of that particular thread will be working on a buffer or registers. It means, what is the meaning for that line is, whatever the value input value you have to give in, whatever the output value we have to get in after completion of this thread, that will be stored in the buffer. It means, why it will be stored in the buffer? That values will be used in the somewhere else, somewhere thread or somewhere in the processing. That's why thread, every time threads will be working in the only in the buffer stage only, not in the secondary storage. Because what happened was, when you have to use the secondary storage, when the output is coming, whenever main process is executed on that time, before display the main output of the process, until then whatever the variable is executed, whatever the program, whatever the thread is, everything will be in the buffer only, buffer or registers you have to use. And the next one is, the threads will be shared by, sharing process will be there. Why you have to use the threads? For example, you are taking the linked list program. What happened was, whenever you are creating the node, the previous, whatever the node address will be stored in the previous node. On that time, whenever you are adding a new node or deleting a node, automatically address have to change. On that time, whatever the node will be created in the previous one, that will be updated. On that time, the threads will be in the sharing the memory or sharing the resources. It means there is a, in between the process and threads, there is a three types of relationships are there: one to many to many, many to one, and one to one. there is a 4 types of things are there. Basically 1 to 1 is a, most of the time it will be not there. Most of the time means 1 to 1 means one process, one thread. Most of the system is not acceptable 1 to 1. Now everyone accepting, most of the time accepting 1 to many, many to 1 and many to many. 1 to 1, why they are not accepting means independent programs are very, very less whenever you executing the program. Independent functions are very, very less in the overall system development or product development. That's why the 1 to 1 is given the less priority in the view of threads. And the next one is, in that thread is also called as a lightweight process. Already explained that why it is called as a lightweight process. Why process is called a heavyweight process. Now, whenever your program is executed, within a program, number of subprograms are there. Each subprogram is called as a one thread. Main program is called as a process. It means main program is one program is there, but 3 subprograms are there. That is called as a one to many relationship. That's why threads are so called as a lightweight process. Because the process is heavyweight means process is the number of combination of lightweight process threads. And the next one is, here threads are, why you have to use the thread? Increasing the individual performance of that particular functionality. Individual performance, increasing the individual performance of a particular method or a thread, and it will be decreasing the overhead of the operating system. It means there is 2 types. What is the advantage of thread means? It is improving the performance of a program and reduce the overhead of the operating system. It means what is the meaning for both the statements is, first, whenever you write down within a program, you write down the one function. Whenever, if the function is dependent on other function, now we have to see that what type of methodology you have to execute, what type of scheduling methodology you have to execute. That will be according to that one, operating system will be perform the operation, and at the same time which method you have to understand depending on the automatically overhead of, it means overhead means the performance of your system. Performance of a system will be increasing, and overhead means it will be cross the limit sometime. It will not cross the limit means you have to see that you have to use some tools, you have to reducing the execution time. On that time we have to consider the classical process. What is meant by classical process? Classical process means whenever you want to executing one function, that function only we have to retrieve from the secondary storage device to primary storage device. It means where you want to execute some program that will be stored in the secondary storage. For example, in the C drive, you have to store as a prime.c. Now, you want to execute a prime.c program. You want to execute that program, you have to retrieve only that program. We have to transfer to the secondary storage device to primary storage device. But whatever the remaining program related to that process will be stable in secondary storage device only. On that time, automatically operating system overhead will be decreasing. In that way, we have to use the thread concept. Now, whenever you are going to the threads, no thread existing outside the process. Whenever no thread outside the process means most of the time no independent process. Independent programs are very, very less. That's why independent process or independent threads also you have to very less whenever you develop the program. It will whenever you have to maintain the independent program, flow of control of that particular program may be differentiate with other programs. Flow of control, how the flow will be going on. It means whenever you are drawing the flow chart, you are checking that flow of the program you have to understand. But whenever independent programs or independent threads are there, unable to identify the flow of thread of that particular program. It means what is the meaning for that is when that program is used in your product or project, we don't know. Just you write down the program, whenever you want you have to call. Which time you have to call, which time you have to use that, we don't know. That type of things are happening during the independent programs. Now, next one is whenever you implement in the threads, nowadays everything is shareable. Nowadays everything is shareable. It means everything with network based topology. It means one server connected with 100 systems. Whenever data will be shared by the shared and data resources also shared in between the 100 systems. For example, you have to go to the photo start, or you have to ask the prints. There is one printer will be there that will be connected to the number of systems. Now what happened is you give the printout on the time before that only that machine is in the working status. Some document is printed, 1000 pages document is printed, but you have the only 2 pages. Until then you have to wait. Until then you have to wait. And after completing the 100 pages printing, then only your printing will be start. It means what happened was, it means you have to, in the network topology, you have to implement like that. When you want to use the another algorithms, if you use the another algorithms, automatically you have to see that. If you want to use the bypass technology, we have to directly, if that printer is busy, go to the another printer, we have to print out, take the printout. That one also there in the right now, in the network shareability. Whenever the 100 pages, instead of waiting more than that, sometime if you waiting that, automatically deadlock will occur, starvation will occur. Due to that, your whole process will be blocked, whole network will be blocked. That's why we have to take care about the threads or process without deadlock, without starvation will occur. In that way, we have to synchronizing the process threads and operating system files. And next one is, we have to find out the parallel execution. We have to identify the parallel execution. Without knowing the parallel execution, you are unable to find out the process and threads. What is the meaning for that is, in the parallel execution, what happened was, we have to parallel execution. Once you have to go to the parallel execution, we have to two process at a time. You have to parallel, like a railway track. It means, I will give the one example for parallel execution. You have the one account in a bank, but your father deposit the some amount in your account. At the same time, your sister or brother also deposit some amount. Which transaction is first executed? That is the main task here. Beginning stage, what happened was, depending upon the processing speed, depending upon the network speed, depending upon the server type, if it is a local server, it will executing immediately. If it is a other state server, automatically takes some time. Now, whenever your father will deposit another bank with the same city, same state. Now, your father deposit 1000 rupees, that will be account is updated. Once account will be updated, before account will be updated, your brother also put the some money in your account. Both the things, your account is updated and your brother added some amount, both the things are ready. It will be done parallelly. That is the concept. That is the concept of parallel execution. Without delay, we have to execute. That is called as a synchronization. That is called as a synchronization. It means in the next slide, I have to explain about how the process will be executed. The single process, single thread, single process, multiple threads. Single process, single thread, single process, multiple thread. Now, here, whenever threads will be executed, single thread and single process. Now, what happened was, single thread will be there. It means your coding will have the only one function. You think about that, only one function will be there. Now, whatever that data will be required, data and files, register and counter and stack. Why you have to use this one? Whenever your program is executed, the program will be stored in the secondary storage device, that will be transferred to the main memory. Main memory means that is the buffer, whether it is stored in a buffer or register. Both are temporary locations. Now, whenever the program is executed, PC, program counter, is incremented. Whenever, for example, initialize a variable I is equal to 1. I is equal to 1 means I is equal to 1. That is a program counter is 0. Next step is I is equal to I plus 1. That program, what is the use of program counter? It will be showing the address of the next memory location. Address of the next memory location. It means I is equal to I plus, where it will be stored I is equal to I plus 1. Next I value will be changes. That will be stored in the counter. How the stack will be there? Depending upon the infix notation, what type of notation you have to follow. Infix, postfix and prefix. According to that one, data will be updated in a stack. These anything program container, these 5 things are common. Here the single thread means single function is working with the code. That is a single process and single thread. Now this is also same thing. This is the one process, this is the one process, this is the one process. Now this is the one thread, this is the one thread, this is data and files are common. But whenever multiprocessing, many to many relationship is there, we have to execute concurrently with the synchronization manner. What type of algorithm we are using? There is a lot of algorithms are there. In the next session, we will explaining about the algorithm. Depending upon the algorithms, what type of algorithm, what type of schedule algorithms you have to use, depending upon that, your threads are executed. That's why beginning itself, the threads are in the three types of relationship between the process and threads. Actually, there are 4 types, but not considered as a one-to-one, because no independent process are executed. That's why they are not considered about a one-to-one. There are remaining 3 are one-to-many, many-to-one, and many-to-many. That's why threads is the most common criteria whenever in the program is executed. Next one is advantage of the threads. Next one is in the threads, context switching is a common. What is in the previous session I have explained the context switch. Context switch. It means, for example, in the server will be connected in the 5 system. Each system allocate the 1 second, 1 millisecond, 1 millisecond, 1 millisecond. According to the time sharing system, we allocate the 1 millisecond. Now, whenever you allocate the 1 millisecond, after that it is not completed the execution, thread is stored in the buffer. You have to stop in the middle of the session. It means stop in the middle of the session means we have to, after 1 millisecond over, that thread will be in the waiting state. another thread will be coming to the execution. That's the whenever context switching, you have to change the behavior of the program. It means change the behavior of the state. That after 1 millisecond over, what happened was that will be convert execution state to waiting state. That is called as a context switch. Context, overall meaning will be changed. Context change and what is whenever English, in the English, whatever context change means, you have to change the behavior. In this context, in the process and threads, what happened was you have to change the state. Change the state is called as a context switch. And next one is threads provide the concurrency control within a process. Within a single program, number of threads will be working out. On that time, concurrency control and synchronization is mandatory. That will be automatically created by the operating system. Next one is efficient communicating between the threads. It means already explained the IPC, inter-process communication. That is called as a two-way communication. There is two types of communication. There is a asynchronous message transfer. If it is a synchronous, what happens? If it is asynchronous, what happens? That is you have to maintain the efficient communication between the threads. And the next one is economically you have to create a context switch, but that is also one of the disadvantage. Economically you have to create context switch, but re-assuming the task is a very, very difficult task. Re-assuming the task is very, very, what is meant by re-assuming? I will give the one example for that. You drive a vehicle at a 70-80 speed in the main road, suddenly you got the speed breaker. What happens? You have to go to the minimum speed. It means that is a 0 speed. Then you have to cross the speed breaker. Again you have to start up. It means how much time it takes? Minimum. Again you have to come back to 70 speed, means it will be take 10 to 15 seconds. It means 10 to 15 seconds is the highest time in a computers. It's a very, very difficult task. That's why context switching is one of the bad thing for the processing. One of the bad thing. That is the criteria. Now, context switching method is what happened is practically it's a very, very good method, but economically that is a very, very bad. There is a lot of processing speed and RAM you have to increase. RAM size sometimes is not compatible. Why? Whenever you try to go to again you have to go to the 70 speed, automatically you have to raise the accelerator. At a time you have to raise the accelerator, means automatically your vehicle lifetime will be decreasing. At the same time, whenever you re-assuming the task that is in the sleeping mode, at a time you have to task will be implemented, means automatically some of the processes not turn up to it takes some time to turn up to the sleeping state to ready state. It takes a lot of time. You have to wait until, otherwise it's a very, very difficult task. Now, whenever the difference between the process and threads. Now, process is a heavyweight, threads are lightweight. That is the first point, already explained that. And next one is a process switching method is included. In the process, switching method is included. Threads switching will not be included. Need to be interact with the operating system. Depending upon the operating system strategy, you have to include the context switch for thread. Process you include the context is very easily, but threads is very, very difficult task. because I've explained in the 1 minute back, resuming the task is very, very difficult in the thread. And next one is, in the process, multiple process environment is executed. Threads will be open to multiple tasks, and child task will be considered, because one process have the multiple threads. Once child process will be completed, all the threads will be executed, then only actual process will be. Until then, you have to wait for the process. But if you take more than, if threads will be executing more than what you are expecting, automatically deadlock will occur, starvation will occur. That is the major problem in the threads. And one process is blocked, no other process can be executed. Here, one thread is blocked, other process you have to execute parallelly. There is no problem about that. And next one is, in the multi-processing system, you have to shareable memory, shareable resources are compulsory. In the multi-processor, few shareable resources, and when compared to process, here very less will be there. And why it is called as a less? Threads will not be connected to the, with respect to the process, threads will be connected. Individually, threads are not connected to any shareable items. Through process only it will be connected. That's why fewer resources will be connected. That is the difference between the process and thread. And multi-threading models. Multi-threading means, already explained the network model. In the all the thread concurrently we have to execute, and concurrently we have to processing that, and what depending upon the what type of algorithm we have to use. If the process is blocked, we have to wait until unblock that process. And multi-threading models are three types. Multi-threading means the concurrent process are executed at a time using synchronization methods, whether it is a parallel or concurrent. Three types are there. First one is a, already explained, many to many, and many to one, and one to one, and many to one. These are all the things we have to use. And what are the multi-thread models? Now, whenever you seeing the diagram, process are 2, threads are more, that will be shareable. There is a multi-thread models in the Unix. There is a 2 types. One is the user space and a kernel space. Kernel space means that will be operating, along with operating system you have to execute. User space means user write down the programs according to that one. We have to take the kernel space, then we have to execute. That is the multi-threaded models. And that is, we have to 2 process, all the threads will be shareable. One process related to this, it will be executed in process 2. Process 2 thread will be executed in the process 1. That is called as a multi-threaded model. Now, advantage of a multi-threaded model. Now, responsive. In the multi-threaded model, response is very quick. Response is very quick. It means we have to use the best algorithm. All the resources are shareable. Bypass technology you have to do that. That's why response is very quick. And next one, economy. During the economy wise, it's very, very fast to execute. Automatically, your programming task will be completed very quickly. Your task will be completed very quickly within a less time. Next one is a resource sharing. Whenever in the multi-threading, resource sharing is a common. Whenever resource sharing will be there, automatically your task will be completed very easily. And the next one is utilization of multiprocessor architecture. Whenever multiprocessor architecture, multi-threaded architecture, or network architecture, or time sharing system, these are all the common things. Multiprocessor architecture. This is supporting for the multiprocessor architecture. It means one server will be connected to the number of systems. All the resources are shareable. All the programs are shareable within the network. Anytime, any people can access. Anytime, any people can execute the programs. If the one person is absent one day, Automatically you never stop the work. Other person allocate that work, we have to complete the task. In that way, utilization of multi-programming tasking is executed. And in this today's concept, in this session I will explain about the thread, how it will be executed in the thread, what is the difference between the process and threads, and advantages of the multi-threaded model and multi-threaded concept. This will conclude the today's session. అయిపోయింది సార్. ఏ సార్ ఇదంతా థ్రెడ్ సార్, రేపు చెప్తారు అక్కడ.
రేపు అక్కడ ఎక్కడ
కెమెరా
ఇవాళ చెప్పొచ్చుగా.
థీరీనే సార్, రేపు ప్రాబ్లం. అంత థీరీనే ఇవాళ, థీరీ ఏం చెప్తాం.